All right, welcome. We're going to do some basic limit laws today. Here is a statement of the theorem. It's really what you would expect. It says if the limit as x goes to a of f of x and the limit as x goes to a of g of x exist, and that's an important assumption, by the way. If one of those don't exist, then these conclusions are just false. Then, number one, the first says that if you have a constant k times f of x, that constants pull outside of the limits. Okay? This is only constants. Constants and constants alone always pull outside of the limits. It'll be k times the limit as x goes to a of f of x. All right? Limit law number two says the limit of a sum is the sum of the limits. So if you want to add up f of x and g of x and see what together that sum converges to, you might as well just see what f of x is getting close to and add that to what g of x is getting close to. The third one is the limit of a product of the limits. So if you want to see what f of x times g of x is getting close to, then figure out what f is getting close to and multiply that by what g is getting close to. Okay? And the last one is the same thing except for quotients. Limit of a quotient is the quotient of the limits. But this one has an important extra requirement, and that is the denominator can't be 0. Otherwise, obviously, it just would be wrong. So watch for that one. That's the main, about the only one you can screw up if you forget to check to make sure the denominator is not 0. If the limit as x goes to a of g of x is not 0, then the limit of the quotient is the quotient of the limits. And that's it for the basic limit laws. Okay? What this really says is, if you want to figure out a complicated limit, you can just figure out the limit of every little piece individually and then assemble it together. Again, making sure that the denominator is not 0. All right, these are all the basic limit laws. You should sort of know all of them well. I'm going to add an extra one here that I wouldn't just memorize, but it's useful in this section and later will be kind of a result of a much more general thing called continuity. So don't view this as a basic law, but just for the time being, for this section only, it is a law. It says also for real numbers, r bigger than 0, and if your function is at least 0 everywhere, then if you do the limit as x goes to a of f of x to the rth power, you might as well have just figured out what the limit of f of x was and then did its rth power, like a square or a cube, or if r is a half, a square root, things like that. All right, let's do a couple examples here. These really make taking sort of many types of limits easy, because again, you just do it piece by piece. So here we go. The limit as t goes to minus 1 of t plus 6 all over 2t to the 4th power. Well, the t is getting close to minus 1, so the top is just going to be getting close to minus 1 plus 6. And here this t is getting close to minus 1, so the bottom is getting close to 2 times minus 1 to the 4th power. So we get 4, we get 5 over 2. Anyway, So that's it. You did this complicated looking limit by just analyzing each piece and see where it was going. Here's another example. Let's do the limit as t goes to 3 of t to the minus 1/4 all times t plus 5 to the 1/3. Now I'm going to rewrite this. This negative exponent means it's really in the denominator, right? So I'm going to rewrite it with it in the denominator just so I can eyeball that I don't have any zeros going on there. Because if so, then I wouldn't be able to calculate the limit this way. So it's t plus 5 to the 1/3 power all over t to the 1/4. All right. So now this t is going to 3. Luckily that's not 0, so that's no problem. So the bottom will be converging to 3 to the 1/4. And this t is converging to 3, so the top will be converging to 3 plus 5 to the 1/3. So we get 8 to the 1/3 all over 3 to the 1/4. And 8 is 2 cubed, so it's 2 times 3 to the negative 1/4 power. If you want to write it that way, and you can write it lots of other ways. All right, so there you go. Calculate limits little bit by little bit. Don't divide by 0. All right, ciao.